This is discussion section for ECS 132, week 3. I apologize for the delay in posting this section, and to make up for that, the next section will be up and running on Monday, on that is the 13th of July, which will be more R intensive. This particular discussion just goes over the homework questions, gives you a little conceptual theory of expectations and variances, and also gives you a simulation on the Monty Hall problem. So without further ado, let me just start with the homework 1 simulations. The first question was, you had a roulette game, you got values from 0 to 10, and you spun it 3 times and you added the values you saw, and you wanted to find the probability that you get a value of 10, sorry, get a value of 15, given that on the first spin you had a value of 2 or a value of 3. Alright, so let's run the simulation. The function value of stored is equal to 15, x1 is 3. You sampled the values out here from 0 to 10. You got the values. You knew that the first one was 2 or 3, so you put the values of x1 right there. You found the total as x1 plus x2 plus x3, and you just found this value of sum, where if x is equal to total divided by number of repetitions. So sum x is equal to total was the number of times you will have the value of the sum as 15. Okay, next one is, consider the aloha example where x1 is not equal to x2, and you have to find the probability that there were 0, 1 or 2 collisions during the 2 epochs. So now it was very simple. If you had just followed the code I had sent you initially during the homework help, or even during the office hours that we discussed, where you just had to run the 2 epochs, epoch 1 right here and epoch 2, find the number of collisions that occurred, numcol, and just increase the number of collisions on both of them, and just find the number of times x1 was not equal to x2, and keep on increasing the value count here. Now the biggest error that the most prominent error was that everybody has reported the values of the number of collisions upon the number of repetitions, but they did not factor in the fact that x1 is not equal to x2 has been given. So it should have been the number of collisions upon the number of times that x1 was not equal to x2. Sorry, the number of times the collision was 0 divided by the number of times x1 was not equal to x. Let me just write this down. Okay, instead of this, what the people have written was the total number of repetitions, which was wrong. Now the third one was, we dealt a 5-hand card, which is large. What is larger, p of 2 aces or p of 3 diamonds? The probability of getting 2 aces or 3 diamonds. Now this was one of the most easiest solutions I had, was when you could just simulate the whole deck of cards as 1 to 52, show that the first 13 were diamonds and the second 13 were hearts, and so on, and just find the values. Like if I'll just write this down here. This was the easiest solution. 1 to 52 cards were simulated, and 5 cards were sampled out of the 52. And then you just check the values. Like, so if I say that 1 to 13 are diamonds, 14 to 26 are hearts, 27 to 42 were clubs, and 43 to 52 were spades. Okay, so sorry, this would be 39. I'm sorry. Right, so if you said that, the first one would have been for every card. So every card in the 5 card hand, just check if it was less than 13, less than equal to less than 14, then that would have been a diamond. And if for every card modulo 13, if the value was 1, that would have been an ace. So you could just have counted the times you had an ace and the number of times you had a diamond, right? And similarly here, this was one of those. This was discussed in the office hours. Another one is where you say that the first four are aces, the next four are twos, next four are threes, next four are diamonds. And that's what they do here. That is the intersection of a deck that is 1 to 4 is, if that is equal to 2, that is two aces have been formed. And similarly 5 to 17 represents the 13 diamonds. And um, yeah, pretty much that's it. Like if there are three values in that deck between 5 and 17, then you have three diamonds, and you return the values of the number of aces upon the number of repetitions. So the number of times you had two aces upon the number of repetitions, and similarly for number of times you had three diamonds upon the number of repetitions. That should have been the three simulations. Majorly, the problem here was, no, I think this was pretty solved. Like there were good attempts on this question. The major problem here was, as I discussed, it was the number of times x1 was not equal to x2 was not considered, and just the denominator was the number of repetitions you had done. And this was also pretty well attempted. So yes, now next I would really want you to go to these two videos, look at the theoretical aspects of expectations and variances, and an example solved for the probability mass function. Oh, also this is the Monty Hall problem. Sorry, I missed this. Right, so this is the simulation for this discussion. Next discussion, we'll be looking at the distributions, Poisson binomial, and I think exponential as well, and which will be heavier in R coding, so that will be more insightful. So let me know if you have any questions. Feel free to drop an email to me, and thank you so much, and I apologize again for the delay in posting this discussion section.